Alright, this is day 6 in our unit on everything to do with exponents and exponential functions. Today we'll be focusing on graphing exponential functions. And we are going to make heavy use of our good friend, the TI-30 XS Multiview. If you do not own one of these, I highly recommend buying one. $15, Amazon.com. Gets it done. Let's see, make your own table of values and graph each function. Yeah, so here's a function, 3 to the x power plus 2. Put this in your calculator. So just hit the table button on your calculator and you will get to here. And so we have 3 to the x power plus 2. So we will just write 3 caret x power. Alright, have to get off of there. Otherwise, if I didn't hit the right arrow key, I would have put that plus 2 up in the exponent. We don't want that. That's a completely different function. I can scroll around. Just hit enter a few times, and what you get is a table of values. Alright, so what you really want to do is graph as many points as you can. Make your own table of values. Okay, so I'm just going to squeeze my table of values in right here, x and y. Let's scroll around and see where the values are useful. Alright, you know what? You got all these fractions over here. If you right click over here and click on toggle, it shows you the decimal version of this. Okay, so at -3 we had 2.03. At -2, we have 2.11. Let's see. I'm just going to keep going. -2, -1, 0, 1, 2, 3, and see what we have. So at -1, we have 2.33. At 0, we have 3, and let's see, I can get a couple of these now that they're regular numbers. So I've got 3, 5, and 11 at 0, 1, and 2. Alright, that's already taking me to the edge of my graph, so that's really you know, if I go to 3, it's 29, so there's no way that's going to be graphed. So that's going to have to be enough values. Okay, so we made a table of values. Now we can graph the function. It's really just that easy. Look, there's something called an asymptote. When we graph these functions, you're going to see that the values are getting closer and closer to a number. You see I have 11, 5, 3, 2.33, 2.11, 2.03. Maybe you can see, especially in this area here, that the values are getting closer and closer and closer to 2 as I go, you know, as my x values get lower. Let's see if it will ever get less than 2 if I keep going. Alright, if I keep going in the negative direction, okay, so here I've skipped a couple, but let's look at that. You'll notice it's 2.004. If I go more, a couple more, 2.0004. So hopefully you can see that it's getting closer and closer and closer to 2, but going further to the left, you know, lower x values, I'm not getting past 2. It's always 2 point something. I'm just getting closer and closer to 2. This value of 2 is called the asymptote, and it's coming from this part of the equation right here. Okay, so for example, looking at this graph, these values will get closer and closer and closer to -4. These values are going to get closer and closer and closer to 1. Okay, so we expect that, and we will graph that as a dotted line. Okay, I'm going to use blue for my asymptote here. Okay, so getting closer and closer and closer to 2. So here is the asymptote that we are getting closer and closer and closer to as we go to the left. Now I can do my graph. So -3 is 2.03. So here I am at -3 and 2.03. It's basically going to appear like it's touching the line. All right, a true asymptote, the graph never actually touches it, but because all ink has thickness, it's going to look like it does. The -2.11, same thing. All right, it's basically going to appear to be touching the line, but in reality, the curve never reaches the asymptote. -1 is 2.33. Okay, so that's a little bit of a visible rise. And then suddenly at 0, we're at 3. So we're up to here by now. And then at 1, we go to 5. So that's 3, 4, 5. And then at 2, we're at 11. All right, so which will actually be 1 off the graph. Now, if we continued this curve, it would, as you saw in the calculator, it's going to get closer and closer to this asymptote but never reach. So if I drew a nice curve through it, it would look something like that. Okay, so this is what your classic exponential function looks like. Exponential functions are either going to be increasing from left to right, like this one is, or sometimes they will be decreasing from left to right. And we'll see that in a moment. Anyway, let me zoom out a little bit so we can answer these questions. Now the domain. The domain, of course, is how far a graph goes from left to right. Well, this curve goes to the left forever, and it drifts to the right forever. So the domain is going to be -infinity to +infinity. The range is going to not be so unlimited. Now, does this graph go up forever? Yes, it does. It does go up forever and ever and ever. So on the right-hand side of my range, I'm still going to have +infinity. But does this graph go down forever? Well, no, this graph doesn't go down forever. There's a nice floor here, the asymptote. It acts as a floor. It gets closer and closer to it, never reaches it. So the graph does not go below 2. So I'm going to write 2 as kind of the floor here. Now, sometimes we use a square bracket, but that would mean that 2 is part of this set, part of the function. But like I said, the asymptote is something that you never quite get to. As you saw in the calculator, I have at -3, I'm at 2.03. At -7, I'm at 2.0000 something. But never quite 2. So we're going to leave this around parentheses to show that 2 is not actually ever reached. Now the y-intercept. You can see that the y-intercept is right here, 0, 3. The y-intercept is always 0, something. It's right there. So 0, 3. The asymptote. This asymptote is a horizontal line. And horizontal lines have the equation y equals a number. In this case, y equals 2, because it's a horizontal line at a y value of 2. Now, as far as the end behavior, we're basically saying what y value does the graph approach in each direction. So this first part that says as x approaches -infinity, That's just a fancy way of saying as the graph goes to the left. Now, as this graph goes to the left, what happens? Well, as we discussed, because of the asymptote, as the graph goes to the left, it gets closer and closer and closer to 2. It approaches 2. So the end behavior, if you will, is as the graph goes to the left, the y value approaches 2. Okay? The value of the function approaches 2. Now, this as x approaches positive infinity, that's just a fancy way of saying as we go to the right. So basically this part is saying what happens on the right, and this part is saying what happens on the left. On the left, the function approaches 2. But as you go to the right, the function doesn't approach any particular number. It just goes up and up and up forever. So on the right, we're going to say the function approaches positive infinity. Okay, so when this end behavior, it's just what happens on the left, what happens on the right. Okay, that's it for, oh wait, increasing or decreasing. Always answer this question from left to right. So from left to right, you can see this graph is always, always, always increasing. We'll just circle that. All right, let's move on to number 2. Okay, in the back of your mind, understand that this is going to be the asymptote right here. All right, so expect the graph to get closer and closer and closer to -4. If you wanted to, you could go ahead and draw in that horizontal line right now. 1, 2, 3, 4. Let's put our little dotted line. This is going to be the asymptote. Now, this graph was increasing. One way we knew ahead of time that it would be increasing is because of this value right here. Whoa. This value tells us it's going to be increasing because it's greater than 1. If this value is greater than 1, the graph is going to be increasing, meaning it will flow upwards from left to right. Now, by contrast, as we look at problem number 2, this value right here tells us that it's going to be decreasing. It's decreasing because it's less than 1. If this value is less than 1, that tells us that this graph is going to be getting smaller and smaller and smaller as we go from left to right. So just watch out for these features. But let's go ahead and put this in our calculator. 1/3 to the x power minus 4. So consult your TI-30 XS Multiview. And I'm going to type it in exactly the way it looks on the paper. 1/3. Okay, I'm going to do the parentheses and everything. To the x power minus. Whoa, see what I messed up a little bit there. I tried, but I must have missed. See how the -4 is up there in the exponent? It's not supposed to be. So make sure that you use your arrow keys to avoid that. So right arrow gets me back down here. -4. Okay, those are some big numbers. All right, let's get down into the realm. Even 23 is too big. And this is really how I go about picking which values I'm going to use. I look at my table ahead of time and I see which values will fit. And 23 was not going to come close to fitting. -2 is the first one that has a shot. So when I make my table of values, I'm really going to start with -2. Okay, so x's and y. So I'm going to do at least -2, -1, 0, 1, and 2. And that might be it. Try to get at least 5 values going. So let's see what we have. At -2, I'm at 5. So I've got 5, -1, and -3. Alright, so 5, -1, and -3. Let's see what else. Okay, now the decimals begin, my friends. Remember, if I highlight it and toggle, it will give me the decimal form. So this is -3 point, I'm just going to go ahead and say -3.7. One decimal place is really all you need here. Okay, and remember, we knew that -4 was going to be the asymptote. We know that as we go to the right, this curve should be getting closer and closer to -4. So I'm expecting, I'm already very close to -4 right now. So I'm expecting this is going to be -3.9 or something like that. Okay, so I go down again, toggle it, and sure enough, -3.88. Okay, that's basically -3.9. Okay, so this will do. Let's go ahead and graph these. So -2, comma 5, -1, -1, 0, -3, 1 is -3.7, and then 2 is -3.9. Okay, so I see what's happening here, and the next one would have been at 23 somewhere. So I know this graph is curving and getting closer and closer to this asymptote. So let's basically connect the dots. I say connect the dots, but make sure you don't stop your graph here. Continue it all the way to the edges of your graph, guys. Alright, so my curve is going to look something very much like this. Alright, so there we go. Now let me zoom out so we can answer some questions. Alright, we're supposed to know the domain. The domain for all of these functions is going to be -infinity to +infinity because they go left and right forever. The range, once again, there's a floor. The floor is -4. So, and then it goes up from there. So -4 to infinity. Again, I'm using around parentheses because the curve gets closer and closer to the asymptote, but it actually never ever reaches it. If I kept looking at these values, it would go -3.9, -3.9999999. It never gets to 4. So we show the round parentheses to show it never gets there. The y-intercept, okay, I see the y-intercept right there. It's always 0 comma something, 0 comma -3. The asymptote is the horizontal line, so it's always of the form y equals something. In this case, y equals -4. Do not just put -4. Y equals -4. Now the end behavior, remember, this just is asking us what happens on the left and what happens on the right. Well, as we go to the left, this time the graph goes up, 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 up. So that means the function approaches infinity. As we go to the right, the graph gets closer and closer to -4. So the function approaches -4 as we go to the right. Alright, and is this increasing or decreasing? Well, as we go to the right, it's getting less and less and less and less. So that is decreasing. Again, we knew that right from the start because this value is less than 1. So, with that in mind, look at this next one. You should be able to tell me right now whether or not this function is increasing or decreasing. 2/5, that's going to be decreasing because it's less than 1. So I already know this is going to be decreasing. And I already know that this is going to be the asymptote. Alright, so in fact I'm going to go ahead and draw that asymptote in. So there's going to be asymptote at +1, so that's going to be like this. Let's go ahead and draw that in as a dotted line. Let's put this in our calculator. So this should be decreasing with an asymptote at 1, so this graph should be similar to number 2 in the fact that it should be getting less as I go from left to right. To the calculator, 2/5 to the x power +1. Okay, so 2/5 to the x power. Get out of there. Get out of there. +1. Double check. 2/5 to the x power +1. Yep, hit enter a few times and see where we stand. Okay, let me see when these numbers get too big. Let me take a look. Toggle. I'm at 7.25. That's doable. That's at 40. Okay, I've overshot. That's 16. Okay, so -2 again is going to be really the first value that fits. So I'm going to do my graph using these values. So x and y, we will do -2, -1, 0, 1, and 2. I'm picking this because -2 is the first value that fits. At -2, we've got 7.25. At -1, all right, we've got 3.5. At 0, we've got 2. And then we've got 1.4. And then we've got 1.2. All right, I'm going to round that to 1.2. Okay, and we're in the numbers, we begin to see what we predicted. There's an asymptote at +1. So as this graph goes to the right, it should be getting closer and closer and closer to +1. As we got closer, here we're at 1.4, 1.2. If we kept going, I'd expect to see 1.1, 1.000 something, and so on. So let's graph it. -2 is 7.25. All right, so it's 7.25. -1 is 3.5, so there's 3.5. 0, 2. 1 is 1.4, it's a little less than half. And 2 is 1.2, so that should just be just above the line. All right, just draw a smooth curve through those, and that's it. All right, this graph is going to look like this. Let's answer the questions. The domain. By now we've seen that the domain for all of these functions is going to be -infinity to +infinity. Exponential functions go to the left forever and to the right forever. That's why. Now the range is how low it goes and how high it goes. There is a floor. The floor is +1. So the range is going to go from +1 to infinity because there is no ceiling. Okay, it goes up forever. I use round parentheses on the 1 because the graph approaches the asymptote, but it never actually gets there. So we will not include the 1, we will show that with round parentheses. The y-intercept is always 0, something, so there it is right there, and there it is right there, 0, 2. The asymptote, we knew it would be 1 because of that number hanging off the end right there. It's a horizontal line, so we will say y equals 1. End behavior is what happens on the left and the right to the graph. As we go to the left, this goes up, up, and away. So that is positive infinity. As we go to the right, this graph gets closer and closer and closer to positive 1. So we will say the function approaches positive 1. This is decreasing, which we knew from the beginning, as soon as we saw that this value, this base, was less than 1. Alright, what else do they have for us? Alright, this is all kind of more of the same. This one should be increasing and with an asymptote at 3. This one should be increasing with an asymptote at -7. Alright. Okay. These next two problems are going to be exactly the same as the ones I just did. So I'm not going to sit here and record this in detail. So I'm just going to make a table of values and show you what the graph looks like. Bam! Here's the table of values that I decided to go with. Bam! Here's the asymptote. Brat! Here's what these points would look like. I decided to stick one extra on there. Even though it didn't quite fit, it's so close it's easy to graph. Here's what the curve would look like. Domain, negative infinity to positive infinity. Range, 3 to infinity. Y-intercept, always 0 comma something. There it is, 0 comma 4. That's a 4, man, it's ugly 4. Asymptote, 3. Y equals 3. Don't forget the y equals part. Increasing from left to right. It goes up, so that's increasing. We knew it would be increasing because this value is bigger than 1. End behavior. On the left, it gets closer and closer to 3. On the right, it goes to infinity. So on the left, the graph approaches 3. On the right, the graph approaches infinity. Okay, almost just like the last two that I did. This one's going to be the same thing. Alright, here's the table of values I decided to go with. Here's the asymptote. We knew it would be at y equals -7. I really could only get these 4 points that were going to fit. Alright, everything else starts rounding to -7 and it goes way off the graph, so I really only got 4 points to work with this time. Alright, this is not the best looking graph I've ever seen, but what are you going to do? Alright, let's answer the little questions at the bottom here. Domain, range, all that good stuff. Yeah, the domain. Of course, the domain will be negative infinity to positive infinity. Alright, as all exponential functions have. The range, bottom to top, this floor down here is this asymptote, which was at -7, of course. So this is doing -7 to positive infinity. Okay, so that's the range. -7 to infinity in that order. The y-intercept, alright, that's the y-intercept right there. It's always 0 comma something. In this case, 0 comma -6. Alright, so 0 comma -6. The asymptote, of course, is y equals -7. Do not leave off the y equals part, please. We knew right from the beginning this would be an increasing function, which it is, because this base is bigger than 1. So it is increasing. So I'm just going to circle that. End behavior. What happens on the left and what happens on the right? On the left, the function, okay, as we go to the left, this gets closer and closer to the asymptote, closer and closer to -7. So on the left, the function approaches -7. On the right, as we travel to the right, the graph just gets higher and higher and higher. So on the right, the function approaches positive infinity. Okay, that's the end of those guys. Now let's look at number 6 and 7. I think these are the last two. Oh, okay, there's a little down there. All right. Sketch the graph of a function that represents exponential decay. All right, exponential decay, that's when it's decreasing. So, so we need one that's decreasing with an asymptote at 3 and a y-intercept at 0, 4. Okay. All right, let's make an equation that will get this done. Let's see, first of all, if we want the asymptote to be at y equals 3, all right, then we know it's going to have a plus 3 on the end of it. So there's my asymptote of 3. If we know that we want it to be decreasing for decay, we need something that's going to be less than 1. So we could use 1/2. We could use 3/4 or any number of things, but I'm just going to use 1/2 because that's something that's less than 1. And it's nice and simple. Now, this part about having a y-intercept of 4, 0, 4. I say the easiest thing to do is to go ahead and put this in your calculator now and see where the y-intercept is now, and then we can modify this equation as needed by adding numbers in the front to push this y-intercept higher, or if we need to, or lower, I guess. So here we go. All right, in the calculator, this would look like this. Let's see where that y-intercept is. Let's get to our table of values. Okay, so here's our table of values. Let's see if it's 0. Oh, look at that, 0, 4. Boom! Right out of the gate. So that's looking pretty good. So we will just stick with what we have. And we can go ahead and graph all these numbers, actually. So -2, 7. All right, maybe we should make a table of values on the paper. So x, y, so -2, -1, 0, 1, 2. So -2, 7. What else? 5, 4. What else? Okay, what do we have here? Well, this is going to be 3.5. Okay. And one more. Toggle it. 3.25. And we knew that this the asymptote would be at 3, so we expect this to get closer and closer to 3. Anyway, so I'm going to show the asymptote here in blue. All right, and that's going to be right here at 3, like we wanted. So don't forget to draw your asymptote as a dotted line. So as I graph the rest of these points, -2 is at 7. -1 is at 5. 0 is at 4. And then 3.5 and 3.25. All right, those are the values that we've got to work with. As you draw your graph, it's going to be looking something like this. Okay, it should basically appear to trace the graph here on the end. Make sure you extend it all the way to the edge of your graph in the other direction. So that is how you do that. It satisfies all the conditions. It's decreasing with a decay, asymptote at 3, y-intercept at 4. It's beautiful. All right, look at number 7. We need a function that represents exponential growth. Okay, so I'm just going to use a base value of 2. Domain -infinity to +infinity, well, they all have that. So I don't have to worry about that. The range is from -4 to infinity. Okay, so starting with my base of 2, if I want that range to be -4 to infinity, that just means that my asymptote has to go to -4. Okay, so far I've got this. Now I need my y-intercept to be 0, -3. Again, I'm going to put this in my calculator and see how close we are to being 0, -3 right now. Okay, I didn't have to pick 2, I just picked it because it was the first number I thought of that's bigger than 1. But I could have picked 3 or 4, or technically I could have done like 1.5. But 2 is nice and simple. So let's put this in the calculator. 2 to the x power -4. Let's see what we got. Table button, 2 to the x power. This is not what I wanted. Let's try again. Table button, clear. Okay, 2 caret x, get out of there, -4. Okay, let's just get to the table. Y-intercept is always 0, something. Here I have 0, -3. What did I want? Oh, 0, -3, bam. This is what I wanted the whole time. So let's go. Let's go. So I'm just going to use -2, -1, 0, 1, 2. Okay, so I already know it's 0, -3. What else is on the screen right now? -2 and 0. Alright, so I'm going to scroll up and get those last two values. Okay, so what's this? Toggle it. -3.75. Okay, and one more. Alright, I know that that is -3.5. Okay, now let's graph what we've got. The asymptote, we knew that was going to be at -4. Okay, so 1, 2, 3, 4. So this will be my asymptote right here. Oops, I missed a little bit. Okay, and now I can graph the points. So -2 is -3.75. All right, that's going to be right there. -1 is -3.5. 0 is -3. 1 is -2, and 2 is 0. Okay, I wonder, could I get one more point out of this? If I go to 3, let me see. Let me see if it would fit. 3, 4, that fits nicely. So I'm going to go ahead and include that. Okay, 3 is 4. Could I get one more? 4, 12. All right, well that is off the grid. Not that far. It'd be around there somewhere, whatever. Okay, at least give me these values right here. So if you finish your graph, on the end it's going to appear to trace, but you must show that. All right, and it's going to go like this. Whoa, that's what's wrong. I'm going to have to go back and fix that. Okay, that's getting a little crazy there. All right, very nice. So this would be a nice table of values and a function that satisfies all of my criteria. Notice that the range was supposed to be from -4 to infinity, and because of the asymptote, the range is indeed -4 to infinity. Y-intercept of 0, -3, domain -infinity to positive infinity. They all have that. Okay, last two problems and we're done. Write an equation of an exponential growth function. Okay, well, okay, that's very open-ended. The key is the base. Whatever number I put in the base here has to be bigger than 1. I'm gonna use something different than what I did up here, so I'll use a 3 this time. So as long as there's something bigger than 1 in here, then that's going to be growth. In fact, that's it. I don't need anything else just to satisfy. That would be exponential growth right there. Exponential decay, I just need to put something here that's less than 1 for my base. For example, 1/3 to the x power. Okay? As long as this is bigger than 1, it'll be growth. As long as this is less than 1, it'll be decay. It's important that these are not negative. Technically, if I put a -3 here or a -1/3, that is neither growth nor decay. So don't do that. And we're done. I hope this has been helpful in helping you to get a feel for how exponential functions work. They all look very similar. They all have an asymptote, and they're either increasing like this one or they're decreasing like this one. And if this has been helpful to you, a like or a thumbs up is always appreciated. Either way, I'm sure I will see you on the next video. Peace out.